So, quick intro. My name is Vijay Raja. I'm the Senior Director of Product Marketing at SingleStore. If you haven't heard about SingleStore, we'll talk a little bit about who we are, what we do. But today, we're going to be talking a little bit about choosing the right database for your Gen AI applications. Okay? So let's dive in. So obviously, Gen AI has all been the buzz all for the last, I would say, 6 to 8 months now, right? And customers are increasingly trying to power diverse applications using Gen AI. Everything from chatbots that can do live customer interactions and issue resolutions, to doing semantic search that goes just beyond the word itself or the text itself, looking at the context or the intent of the question, if you will, right? We have seen increasing action in use cases such as image search, image recognition, facial recognition, audio search, so on and so forth, right? So this is the cool part. But I'll tell you what's not the cool part. Our customers trying to power these and some of the other applications. So in a lot of the cases, what customers do is, okay, let's start with an open source database, right? Like a MySQL or a PostgreSQL, and then we'll use that to power the application, which is fine. It starts great, and it's an awesome place to start. But guess what? Now you want to bring in some third-party data, JSON data, semi-structured data from other vendors. Oh, now you know what? I might need a JSON database. I might need a MongoDB, right? Now, as your number of users grow, as your data volumes grow, what happens? Your query performance starts to dip. Now you suddenly need a cache. Oh, now I need to add a Redis to the equation, right? You wanted to now do full text search. Oh, I need to bring in Elastic into the architecture, right? Now, what if I want to bring in some real-time data from IoT data streams or clickstream data? Suddenly, you now have to think about how do I integrate with Kafka? All of this is just on the operational side. What if you want to serve analytics to your customers? What if you want to serve analytics through your applications? You're looking at a whole other host of engines. Let's say a Druid, a ClickHouse, a Snowflake, for example, right? And try and integrate that analytical piece into this, and then to serve analytics to your customers. And now, today, if you want to do vectors, if you want to do Gen AI applications, you're going to add another piece to the puzzle, which is a specialized vector database, such as a Pinecone or a Milvus, right? So as you can see, this is incredibly complex and inefficient way to power your applications. You are stitching together multiple different data engines, databases. You're moving data, you're replicating data, you're ETLing, which I'm sure you guys all love ETLing, right? So there has to be a better way. So again, what this leads to is obviously you quickly run into what? Performance bottlenecks. Your customer experience starts to be affected. You run into scalability bottlenecks. You cannot scale your application as your demands grow. Your data is probably not fresh. It's probably 30 minutes old, or if in some cases maybe 30 days old. I really hope that's not the case. But and guess what? Your costs are going to be skyrocketing because you are duct taping 7, 8 different engines trying to power an application and moving data, right? There has to be a better way, and there is a better way. Introducing SingleStore. SingleStore is a single database that unifies, single database that you can use to transact, analyze, and contextualize some data in real time. Now, what do I mean by that? In plain English, SingleStore DB is a distributed relational database that you can use to process transactional OLTP workloads, OLAP, analytical workloads, and vector capabilities in a single engine, in a single unified engine, without any data movement. So you're like, oh, that sounds too good to be true. How do you guys do that, right? Okay, so let's get into the details. For transactions, we have an in-memory row store that lets you do extremely fast writes and fast record lookups. And as I mentioned, we are a distributed SQL database, which means you can scale up and scale down, obviously, but you can scale out horizontally as your data volumes grow, as your number of users grow. So you can horizontally scale out just by adding more nodes. And that's the beauty of being distributed architecture, right? But apart from the row store, we also have a column store, which we call universal storage, that lets you do high-performance analytical queries on data as it lands. So you can now do large-scale aggregations, complex SQL queries, very easily. And one of the ways which we excel here is when we do queries, we deliver sub-second latencies, usually millisecond response times. And the reason is because of this unique architecture of having an in-memory row store with a disk-based column store combined with the cloud object store. That's what makes this architecture really unique. Okay? Now, the third aspect, which is contextualized, this is what we're going to be talking about today. This is all around the vector capabilities and the AI capabilities that you can use to power Gen AI applications. SingleStore has had vector capabilities since 2017, way before the Gen AI revolution, right? And we already have customers today using SingleStore to power everything from chatbots to semantic search to image recognition, facial recognition, so on and so forth. And today, okay, how does that fit in with your architecture then? So as you can see here, SingleStore, there's a unique feature in SingleStore called pipelines. I don't know why that is blacked out, but think of it as 5 lines of SQL, 4 to 5 lines of SQL that you can use to bring in streaming, parallel, high throughput ingestion, data ingestion, up to millions of events per second from distributed data sources such as Kafka, Amazon S3, Azure Blobs, HDFS, MongoDB, you name the source, right? You can now bring in data in pretty much real time and analyze data as it lands without the need for actually doing ETLing, right? And once the data lands, as I mentioned, we combine transactions analytics in the same engine, so you can now power applications based on data that's coming in, and you can analyze data as it lands. And where does SingleStore run? So you can run SingleStore either on-prem or in any of the leading clouds. AWS, Google Cloud, or Microsoft Azure. You can run this anywhere pretty much. But here is the most important aspect. You can bring in data, you can run this anywhere, but I mentioned we are a relational database, so obviously we support SQL structured data, but SingleStore is a multi-model database, which means beyond relational, you have geospatial, full text search, JSON, key value search, time series, and now vector capabilities. These are all baked into the platform. These are first-class citizens within the platform so that you don't have to tie together 7 different engines to power your applications. So now you can use this to power either your applications or real-time analytics. And we have customers using it for us for both. But the best use case really, if you can think of, is applications with analytics. So if you are serving analytics to customers, or if you have an interactive applications which customers interact with, SingleStore is the ideal choice for something like that. And today we have customers across all over the globe who are using SingleStore to power, cutting-edge applications and analytics use cases. Everyone from 5 of the top 10 banks here in the US to companies like enterprises like Uber, Hulu, Akamai, Comcast, Siemens, GE, just to name a few. But we also have another segment, which is like the fast-growing disruptors or tech disruptors or the SaaS players, right? So if you think about the fintechs, the ad techs, the martechs, the cybersecurity techs, they don't have a lot of legacy baggage. So for them, it's easy to power their application because their application is the product at the end of the day. That's what makes money for them. So they're using SingleStore to power. We have about 150 SaaS companies who are using SingleStore to power their SaaS applications. Okay? Now, given all of this, let's pivot and talk a little bit about Gen AI. How are customers powering Gen AI applications today? And what role does a vector database play? Okay, so Gen AI applications, it's all about vectors, right? When we talk about vectors, there are 3 key things we need to know about. How do you create vectors? How do you store vectors? And how do you search vectors? So when you talk about creating vectors, you can use any of the APIs out there, including OpenAI embeddings or Hugging Face transformers to create these vector embeddings. But once you create those embeddings, you got to store these somewhere. That's where a database comes into perspective, right? And you can use different indexes within the database to store these vectors. Once you store them, the way you power Gen AI applications is through vector search. And the way that you do vector search today is using algorithms such as cosine similarity or Euclidean distance. Those are different algorithms that you use to see how close two vector embeddings are or how far apart different that they are, right? So that you can now generate the next text or the next closest image that matches to those vector embeddings, okay? Now, I'm sure you would have realized you have seen a host of new specialized vector databases that have emerged in the market today. So you hear the name Pinecone, Milvus, VV8, ChromaDB, Zills, so on and so forth, right? Now keep in mind, they are vector-only databases. They handle only vectors. So if you go back to that spaghetti chart I shared earlier, this becomes another piece of the puzzle this becomes another silo or a piece of the puzzle that you now have to solve for, that you have to manage, and of course you have to pay for, right? And there are some other limitations or considerations that you as audience should consider when you're choosing the database. So when it comes to vector databases, most of these have limited or no support for SQL. What that means is you have to write custom code or use custom languages to build your applications, and that really limits you as a developer into what you can do with these applications and limits the amount of analytics that you can do with these. That's number one. Number two, these are vector-only databases, which means they have no support or limited or no support for things like relational data, JSON, time series, geospatial. What if you want to combine vector data with some of the other data sources, right? That's a challenge. And number three, these vector-specific databases are highly memory intensive, they are compute intensive, and they are going to be expensive. And they will take long indexing times, for example. Last but not the least, when you're choosing a database, keep in mind about the enterprise features. Things like ACID compliance, things like HA capabilities, DR, PITR, point-in-time restore, multi-AZ failover. These are enterprise capabilities that takes time to mature. We have built this over the last 13 years, right? A lot of these new databases usually lack maturity, I would say, in terms of some of those enterprise capabilities as well. So what you need for Gen AI applications is an enterprise database that has vector capabilities, not the other way around. You need an enterprise database that can bring in vector capabilities as well. And SingleStore DB is a vector database or a contextual database, if you will, for Gen AI applications. What you can do is you can now support not just vectors, but support for all data, including JSON, geospatial, time series, and more. You need the ability to combine vector data with your transactional and analytical data engines. Why does that matter? So imagine if you're building a recommendation engine or a chatbot, you want to give a recommendation based on just one parameter, or do you want to give a recommendation based on a customer's previous purchases or transactions from the transactional database, from their clickstream data, from the analytical engine, from the support tickets that they have given into the call center, or based on the demographic data that comes from the CRM, right? So you want to be able to combine multiple data types to power an intelligent recommendation back to customers, right? That becomes extremely critical. And also for SingleStore, I talked about pipelines. It makes it really easy to stream in data from multiple different sources and do transformations on the fly as the data lands. It becomes very, very, very easy, right? Last but not the least, vector search is something that's important. On the other hand, text search, full text search, that's also important. But what about doing a hybrid search? What if you want to combine vector search with full text search? SingleStore enables you to easily do that with one SQL query, right? So it becomes fast, easy, simple, and efficient to power your Gen AI applications with a database like SingleStore. So it is a vector database, but it is so much more than a vector database. It's like vector database plus operational engine plus an analytical database plus a multi-model capabilities that you have in one single platform. And I think I mentioned this. So we have had vector functions since 2017. We already have a lot of customers who are in production, who are using this to power very interesting use cases today, and I'll talk a little bit about that. But one of the key ways by which you can do these nearness search, like how closely two vector embeddings are, is what we call dot product function. So those are built-in functions within the database that you can use to understand how closely similar connected two vector embeddings are or how far they are, right? So you can use dot product or Euclidean distance to do the nearness search for these vector embeddings. Last but not the least, we are already integrated with things like, platforms or LLMs like OpenAI, LangChain, Llama Index, and so on and so forth. So you might be wondering, okay, that's great, but how do I use OpenAI to answer questions specific to my data, your internal data, right? So I'm not sure if this was covered earlier in some of the other sessions, but there is an architecture that is coming into relevance, which is called Retrieval Augmented Generation, or RAG, simply put. What RAG really is that when a user asks a question, the question gets converted into vector embeddings. But your application doesn't directly go ask that question to the LLM or OpenAI, because OpenAI has no idea of what your data is. It has no context, right? It only has the data in the internet. So instead of having the app directly talk to the LLM, you want to add a contextual layer in between your app and the LLM. That contextual layer is SingleStore or a vector database, which can add context to your questions. So in this case, SingleStore already has transactional data, analytical data, or it can easily stream in that data from these sources. And when the user asks a question, it gets converted into vector embeddings. And in real time, SingleStore can actually search for vector similarity in near real time to identify what other documents or data sets match to that question, right? So instead of sending just a question back to LLM, now you're sending the question along with additional context, additional intent, additional data, which is then sent to the LLM so that you can get a very specific, targeted, personalized answer based on your own data. Okay? So that's the whole concept of retrieval augmented generation. By the way, we have used that technique to build our own app. We have built an app called Squirrel, which is really a Squirrel chatbot that we built on SingleStore data. What customers can do is they can ask questions in plain English and say, hey, build me a database with these tables and these formats. We can actually give you the SQL code for that. So you can talk to this in plain English and it will convert plain English into SQL. And it can also answer questions specific to SingleStore. Because the Squirrel bot is trained on SingleStore data, based on our own documentation, based on our GitHub repos, based on the support tickets, based on the forums data. So it brings together all of this data. We have trained this bot, and it helps customers answer these questions, right? But then if you're wondering, okay, hey, I don't want to expose any of my data to an open LLM like let's say OpenAI. Well, yes, you can now run these privately using private LLMs as well. We did a webinar where you can actually run this similar architecture using SingleStore with Llama 2.0 all within your enterprise firewalls without data ever leaving your four walls, right? So again, the same concept of RAG or the same concept of using a vector engine to power applications, you can do this very privately within your four walls of the enterprise as well. Okay? And again, in this case, we were using SingleStore with Llama 2 along with Hugging Face and LangChain as the platform to kind of tie this together. Okay? And a number of customers, as I mentioned, are using these kind of architectures to build very, very interesting use cases. Siemens, for example, they are using vector search to do sentiment analysis on survey data. So they do surveys with customers and with their employees. They are using sentiment analysis, doing sentiment analysis using vector search. Thorn, for example, if you're not familiar with Thorn, they are a nonprofit. They are using SingleStore to do real-time facial recognition to identify children's images and then really help prevent child trafficking. And a very interesting use case, which I like personally, is the last one, the Lumix.ai. What they do is they have a platform that does video surveillance and monitoring. So let's say you want to say, hey, find me where if somebody is standing too close to a forklift, alert me, right? So they're bringing in video data to do things like real-time surveillance and do things like hazard monitoring, for example, right, in this case. Or you could say something like, let me know when a blue Tesla with a license plate that has number 9 in the license plate. Alert me when that drives by. So I mean, the opportunities are endless, and the opportunities for these use cases are growing by the day. So very, very interesting field, and a very, very interesting area that we see fast emerging. So I don't have time to go into more details, but if you guys are interested more, please stop by booth 113. We are SingleStore at booth 113, and we can show you a demo. And if you're interested in signing up for a test drive or a speed test, please do sign up. We'll be happy to send some cool SingleStore gear as well if you guys show up. Okay. So hope that helps. Hope that give you some kind of an idea and perspectives on what to look for when choosing a database for your Gen AI applications. Thank you once again, and I'll hang out here if you have questions. I'm happy to address any questions here or later at the booth. Thank you once again, and have a great evening.